Hello, in this segment, we're going to discuss adding and subtracting rational functions and rational expressions. So the first thing to do is just to remind you what a rational expression is. Rational means written as a fraction. So just the most basic kind of rational expression that you could add is perhaps something like this: 2x over x plus 5 plus 7 over x plus 5. And these are just like any other kind of fractions. You need a common denominator. We have that. So the bottom is x plus 5. And then the top is simply 2x plus 7. That is just an example of adding two rational expressions. If you subtract them, it works the same way. Suppose we had x over x minus 4 minus 2x plus 6 for x plus 4. With subtraction, the only thing that you need to kind of be worried about is, and I meant that to both be x plus 4. Okay, there we go. X plus 4 over x plus and x plus 4. They match. The only thing you need to be worried about is that the negative does distribute to both of these terms. So you have a common denominator here of x plus 4. And then x minus 2x makes negative x. And then minus a 6 makes minus 6. So you get negative x minus 6 over x plus 4. Again, both of those have common denominators. When this gets a little bit tricky is when you don't have common denominators. So let's just kind of look at that. That's going to be most of the type of rational addition subtraction that you see. Let's just start with something like, let me find my spot here, 4x over x plus 1 plus 5 over x minus 3. So what you need to do first is just kind of think to yourself, what's a good denominator that both x plus 1 and x minus 3 can go into? And when it's hard to figure that out, one option that's always available is just multiplying the two denominators together. So for example, if this was x plus 1 times x minus 3, and this was x minus 3 times x plus 1, if you had the same two things in each denominator, you would then have a common denominator. So what you need to kind of do now is say, well, I wish I had an x minus 3 here. So we're just going to go in and multiply by x minus 3 over x minus 3. And I wish I had an x plus 1 here. So I'm going to just do that. And now we're going to have on the bottom a common denominator of x plus 1 times x minus 3. And on the top, 4x times x, 4x squared, 4x times negative 3, negative 12x, plus 5 times x, 5x, plus 5 times 1, 5. So you're going to have x plus 1 times x minus 3, 4x squared stands alone, minus 12x plus 5. So there you go. That is your result. If you're doing a multiple choice problem, you might find that the bottom was also FOILed out. That would be fine. If you FOIL this out, x times x is x squared. Minus 3x and plus 1x would make minus 2x. And then 1 times negative 3 is negative 3. Those are exactly the same thing. Either one is just fine. So let's do some more of these sorts of problems. Okay. Let's look at this one. We have a denominator of 5x and 3x. I'm going to know what both of those can go into. Notice they already have an x. That's encouraging. That means this is going to probably be a little bit easier than we thought it might be. 5 and 3, both of those can go into 15. 5 times 3 is 15. This is one where if I want this bottom to be 15, I multiply by 3 like that. And then I want this to be 15, so I multiply by 5 over 5. Bottom, we now have a common denominator of 15x. On top, we have 21. 7 times 3 is 21. 5 times 8 is 40, so we get 61 over 15x. That one is not so bad. Let's try a few more. Okay, on the bottom of this, we're going to have x squared minus 3x minus 18. So, first thing we need to do is figure out the common denominator. It's not as obvious because this bottom right here is not factored. So before you do anything, I want to just go ahead and rewrite that in factored form. X times x would make your x squared. What multiplies to be negative 18 but adds up to negative 3? A minus 6 and a plus 3. That's a x minus 6 times x plus 3. So now, as we look at this denominator and this denominator, we both have x minus 6. We would like to have both x plus 3. So I'm just going to kind of sneak in here and multiply by x plus 3 over x plus 3. And now we will have a new denominator of x minus 6 times x plus 3. On top, x plus 3 times 1 is x plus 3. And then minus 5 results in x minus 2 on top. And x minus 6 times x minus 3 on bottom. That is my answer. You can multiply this out to be x squared minus 3x minus 18 again if you chose to do so. So that's a one where you have to factor the bottom first in order to figure out what you need as a denominator. Let's try a few more here. All right, 2x plus 5 over x minus 10 plus 3 over 3x plus 2. Let's put those in parentheses there. Again, I need a common denominator, 3x plus 2, x minus 10. Nothing comes to mind as to what those both go into, so we're just going to multiply the two together and use that as my common denominator. So here, I would like to have an x minus 10 and a 3x plus 2, so I'm going to just multiply by 3x plus 2 there. And over here, I'm going to multiply by x minus 10. And now I have a resulting common denominator. We'll just write this currently as x minus 10 times 3x plus 2. On top, we have a FOIL situation on our hands. We have 2x times 3x, 6x squared. 2 times 2x is 4x. 5 times 3 is 15x. 5 times 2 is 10. Then over here we have plus 3 times x, 3x, plus 3 times minus 10 is minus 30. And finally, on top we have 6x squared, 4x, 15x, and 3x. That adds up to 22x. And then 10 minus 30 is minus 20. And then on bottom we have x minus 10 times 3x plus 2. You could FOIL that out again, multiply it out, and that would be, you could either leave it like this or just multiply it out. Notice that everything on top is divisible by 2, 6, 22, and 20. If the bottom had something divisible by 2, you could potentially reduce it, but because This doesn't have a nice 2 out front. That's all you can do for now. Let's look at a situation where you have 3 terms that you need to add together. The same principles apply, but it may just be a little bit longer. Okay, we've got, I'm going to do 4x over x plus 1. And then we'll do plus 5 over 2x minus 3. Then we'll do minus 4 over x. Notice I'm leaving plenty of room here. There we go, sorry. Plenty of room to kind of add in the pieces I need. 4x over x plus 1 plus 5 over 2x minus 3 minus 4 over x. Again, we need a common denominator, something that all denominators can share. So it's going to have to be x plus 1 times 2x minus 3 times x all together. I'll put a little equal sign up here. We're going to go to the next line, obviously. So what does this denominator lack? It lacks a 2x minus 3 and an x. So we're going to multiply this by 2x minus 3 on top and bottom. And we're going to multiply by an x on top and bottom. We'll come back to that. This one lacks the x plus 1 and the x. So we're going to multiply this by x plus 1 and over itself, and then x also. And then here we're going to multiply this by, we lack an x plus 1. Do that on top and bottom. And 2x minus 3 on top and bottom. So that's my setup. Everything is going to be found in the denominator, the x plus 1, the 2x minus 3, and the x. X plus 1, 2x minus 3, x. On top, notice we're going to have x times 4x is 4x squared. Multiply that times 2x and you get 8x cubed. X times 4x is 4x squared times minus 3 is minus 12x squared. 5 times x is 5x times x, 5x squared. X times 5 is 5x times 1, 5x. And then over here, we would FOIL this out. You've got 2x times x is 2x squared times 4 times minus, so minus 8x squared. You would have minus 3x and plus 2x if you're doing FOIL, so minus x times 4 times minus is plus 4x. And then negative 3 times 1 is negative 3 times 4 and times negative would be a plus 12. So we're going to add all that up now. 8x cubed on top minus 12x squared plus 5 is negative 7x squared, and then minus 8 is a minus 15x squared. And then we've got 5x and 4x makes 9x. And you could leave the bottom as it is, or you could choose to FOIL it out. 2x times 2 times x, and another x is 2x cubed. We'd have minus 3x and plus 2x should be minus x, but then you multiply times another x and you get minus x squared. And finally, 1 times minus 3 is minus 3 times another x is minus 3x. That would be your completely multiplied out answer. You could also have left the denominator just like that. So in all these problems, what you're doing is you're trying to find a common denominator. If you're unsure what that should be, most of the time you're just going to multiply all the original denominators together. Make sure that each term has either all 3 or both the 2 or whatever it is. You just need to make sure that you include every denominator in that was original in every one of these terms. And to do that, you have to multiply by the 2x minus 3 on the top and the bottom, the x on the top and the bottom, the x plus 1 on the top and the bottom. Everything has to be multiplied on the top and the bottom. If you're lucky enough to have a common denominator to start with, you just either add or subtract what's on the top of the fractions, just like any other type of fraction. I hope this helps. Like I said, this wraps up our adding and subtracting of rational expressions.